We are looking at section 1.4, just a few examples from the homework that many students find challenging. The first one we're going to look at is problem number 4 from section 1.4. This one asks us to find the limit as x approaches 5 from the right of the absolute value of x minus 5 over the quantity x minus 5. This is tricky because it has that absolute value sign. But if you remember an algebraic definition of absolute value, it really just says whatever's on the inside, you make positive. Sometimes absolute value functions are defined as a piecewise function. So if you think of it like that, you have two different situations. You have the expression x minus 5 when you plug in x is positive. And so really you have x minus 5 is greater than or equal to 0. That's saying then x is greater than or equal to 5 when we simplify. And in which case, if x minus 5 is positive, the absolute value bars don't affect it. It just, the expression stays positive. So x minus 5 is going to be equivalent to the output of the absolute value of x minus 5 for x greater than or equal to 5. The other option is it's not positive, in which case it's going to be, the expression is going to be the negative of the quantity x minus 5. And that's going to happen when x is strictly less than 5. Okay. So that's just one way to think about that absolute value function, and that might help you with this limit problem. Then if I use that table or that piecewise defined function, and I look at the limit that I'm evaluating, I am evaluating a one-sided limit, and I'm looking specifically at values of x to the right of 5. So when I consider values to the right of 5, those are going to be things like 5.1, 5.01, 5.001, very close to 5, but still slightly greater than 5. And what we see is an output of x minus 5. So you can think of that. You can get this next line kind of just using, you don't have to write necessarily the piecewise part out, although you might find that helpful. But what you should see is that the absolute value of x minus 5 in our case is going to be equal to x minus 5 because we're dealing with values of x that are to the right of 5 that are slightly greater than 5. So we're always going to get values that are close to 5, but just slightly above 5. So this x minus 5 quantity is going to be positive. And so when you plug it into the piecewise function, it's going to come out as positive. So then here, if we think of this in factored form, we do have to consider that x cannot equal 5, but in this case, x isn't going to equal 5 because we're looking strictly to the right of 5. So then this limit value is going to be, these will cancel. I'm left with 1, and the limit as anything, as x approaches anything of 1, is just 1. The only difference that you might notice is you might have that other expression if we are looking to the left of 5. Now, granted, that is not what we're asked. So if this is going to confuse you, just stop the video here. But if we were looking for a left of 5, just something to note, the only difference is you would have this expression right here. You would have the negative of that. And so when we canceled out the common factors, we would have a negative 1. That's the only difference, in which case the limit would approach negative 1. So for those are kind of two types of problems that you might encounter.